In this video, I want to present to you the 3D handheld scanner series of Thunk3D Fisher. It consists of three models. The first one is the Fisher S.
The Fisher S has both 12 cm and 30 cm light. The single frame accuracy is 0.04 millimeters and it is suitable for objects from 5. The Fisher W has both 20 cm and 30 cm light. The single frame accuracy is 0.1 millimeters and it is suitable for objects from 10 to 200 cm size. The Fisher X has both 40 cm and 80 cm light. The single frame accuracy is 0.5 millimeters and it is suitable for objects from 30 to 500 centimeters. Regarding scanning speed, it records 3 to 4 images per second, with a maximum of 1 million points.
The big advantage of all the models is that they have two projecting light colors. The first one is blue, the second one is a bright white one. So in order to both take images of really dark objects and really bright objects, you can change the colors in order to get the maximum results. And also both of them can be switched for a fine range and for a more bigger range, which covers less detail but accumulates a bigger range of view. So I want to show to you the difference in colors. We just start a new project with the physical object dark. So in order to do the bright colored light, and you can see on the wall with the two laser markers, we have to move both of the points at the same point, and then we can see the bright color. And if we switch this to a new project with the tint physical object property, then it gets the blue light, which is more suitable for brighter objects. What I also can show to you is the range. So if we want our scan mode for smaller objects, we can choose the scan mode as fine, and then our imaging area gets smaller, and you can see on the wall that the actual area is a lot smaller than for the standard mode.
Next, I will demonstrate the Fisher S to scan some different kinds of objects. For this leaf, its veins can be displayed thanks to the scanner's high accuracy of 0.04 millimeters. But how can we merge the two sides? Unfortunately, if the leaf is absolutely flat, it is not possible. However, if the leaf is a little curved, it's possible to complete the full modeling. The stiletto here. The difficulty is that it's small in size and symmetric, so we should use mark align. Under mark alignment, group creations is not available. If we can't scan it completely, as a solution we could use feature alignment. Then by right-clicking, do a group register. In mark alignment, we scan two objects in different positions. Then merge them in a third-party software like Geomagic. Next comes the industry workpiece. Since it has many features, it's easy to scan and change positions during scanning. But be aware of your fingers. Once one of them is captured in an image, the real-time alignment will be disturbed and it will result in incorrect alignment. You also can do a group register where it is easy to scan objects like this one. Now we scan a human face, or ear, or hand, whatever. The output is great. We can see facial pores and wrinkles clearly. The Fisher does a good job on data detail, and the 0.12 millimeter point distance is enough for most of the applications. And for the bust of David, it's no problem to scan it in total. We use a larger lighting area to make the scan more fluently. It has very simple operations actually. With the Fisher W, since it can scan objects from 10 centimeters to 200 centimeters, I will demonstrate both ranges. The camera shell is no problem to scan with fine mode and mark alignment, but the white light can't scan the reflective part, the hollow part and the totally black part. All other features are well performed. Another advantage of the Fisher is that it can build X, Y and Z coordinates on mark alignment, which are automatically stored in a TXT file. You may wonder what this function can be used for. Actually, the more images we scan, the slower the speed becomes, and the worse the volume accuracy is. For example, if I carefully scan this 2-meter part, it takes 300 to 400 images and the volume accuracy may be 2 millimeters. But if I quickly scan it with 50 to 60 images, the volume accuracy can be 0.8 millimeters, for example. To achieve this, we build the X, Y and Z coordinates first. Then start a new project on frame alignment and load the coordinate file. Carefully scan it, and no matter how many images I scan, the volume accuracy is always framed in the coordinate of 0.8 millimeters. This feature of the scanner is very useful when we have high accuracy requirements. The Fisher W could also scan people, faces, busts. It all works very well. But keep in mind, when scanning faces, that the scanning light is not comfortable when it's shining directly into eyes. Lastly, the Fisher X, which is used for scans of oversized objects. For example, full body, cars, or this 5-meter sized studio. The software also features an oversized scan mode, which adds a special algorithm to make the scan faster and more fluently. To summarize the Fisher family, they are highly efficient when it comes to scanning time with better data details. They offer great flexibility with 2 types of lighting areas.